Researchers have found the brightest burst of light ever recorded, but have unearthed further mysteries surrounding it.
Is our world only made up of what we can perceive with our senses? Well, for centuries, this question has bugged some of the finest scientists, philosophers, and academics. And what have we found out? Well, a lot. One notable figure in this pursuit is Daniel Nemes, a scientist who went missing after creating a device to see multidimensional beings. So, what do we know about additional dimensions? Where is Dr. Nemes? And what secrets did he and others like him unearth for us? Let's find out. The enigmatic energy vision device. Notable quantum physicist and researcher Dr. Daniel Nemes has worked tirelessly to push the boundaries of our understanding of reality. His academic journey began with a deep fascination for the fundamental principles governing matter and energy, leading him to obtain advanced degrees in physics. Over the years, he has contributed to numerous studies exploring the behavior of subatomic particles and the intricate interplay of forces that shape our universe. Driven by a passion for unraveling the mysteries of existence, Nemes also ventured into the development of what he called the energy vision device. What is this device? Where is Dr. Nemes? What did he uncover? Well, let's uncover the truth one by one. This energy vision device is meant to visualize entities existing in other dimensions. At its core, the device combines principles of quantum mechanics, where particles can exist in superposition and entanglement, with electromagnetism and advanced imaging technology. By manipulating and detecting specific electromagnetic frequencies, the device can capture phenomena that lie outside conventional perception. This pioneering approach allows for the processing of data in ways that claim to translate invisible dimensions into visual formats. The implications of this technology are staggering. If it indeed functions as described, it could open a portal to understanding the very fabric of the universe. The device has been engineered to emit a range of electromagnetic frequencies, which are theorized to resonate with the frequencies of entities from other dimensions. These interactions are then captured through an array of sensors and translated into visual data using sophisticated algorithms. This process involves a complex interplay of real-time data analysis and imaging techniques that yield photographs of these otherworldly beings. The results, however, have been met with both fascination and skepticism. Critics question whether the images are indeed representations of other dimensional entities or merely artifacts of the device's technology, an outcome of noise, reflection, or interference. In any case, if Dr. Nemes's claims about the energy vision device are validated, the ramifications could be profound, reshaping our understanding of science and cosmology. The implications of capturing images of beings from parallel dimensions would challenge established scientific paradigms and provoke a re-evaluation of philosophical questions surrounding existence, consciousness, and the nature of reality itself. It will also lead to groundbreaking advances in theoretical physics, metaphysics, and even spirituality, as humanity grapples with multiple realities and their implications for our understanding of life and the universe. However, the scientific community has approached Nemes' work with caution and skepticism. Many experts argue that extraordinary claims require extraordinary evidence, and thus far, the supporting data has not convincingly met this criterion. Critics highlight technical glitches as a significant issue, suggesting that the device may produce results influenced by environmental factors, such as electromagnetic interference from nearby equipment or natural phenomena. These skeptics call for rigorous peer-reviewed studies to assess the validity of the images and the technology behind the energy vision device. The controversial images generated by the device further fuel the debate, showcasing a variety of humanoid figures and abstract forms that some believe to be representations of beings from other dimensions. These interpretations have led to polarized opinions. While some advocates celebrate the images as groundbreaking discoveries, others argue that they reflect misinterpretations or misrepresentations of data. The challenge remains in distinguishing genuine anomalies from mere technological artifacts. In the broader context of scientific exploration, Nemes' work aligns with the ongoing inquiry into parallel universes and the multiverse theory. concepts that have gained traction among contemporary physicists. Leading figures in the field have explored the possibility that our universe is but one of many, each governed by its own unique laws of physics. These theories propose that various dimensions could coexist, offering a framework for understanding phenomena that are otherwise inexplicable in a traditional three-dimensional context. This exploration resonates with metaphysical studies, which also contemplate the existence of multiple realities and their implications for human experience. But this is not even the most interesting part. A Reddit user has claimed that the Doctor is nowhere to be seen since May 2024. While his whereabouts are unknown, what is known is that he is not the only one who believes in multiple realities, dimensions, and their inhabitants. The Shadow Biome. Dr. Gary Nolan, a prominent figure in the field of immunology and a researcher at Stanford University, has recently drawn attention for his intriguing comments regarding a concept he refers to as the Shadow Biome. He proposes that there is a hidden realm of organisms that coexist alongside us but remain undetectable by our senses. To put it simply, Dr. Nolan has expanded upon Dr. Nemes' idea, but of course from a strictly biological perspective. He posits that this biome may not necessarily involve interdimensional beings, and he has indicated that a colleague, closely associated with his research, has compiled compelling data on this topic, including up-close video evidence of an intelligence interacting with a specific signal created by the researcher. Could this colleague of his be Nemes? Nolan's claims have ignited discussions within scientific and UFO communities alike, particularly as he prepares to publish findings that could significantly alter our understanding of biological diversity and consciousness. He is not alone in proposing the existence of such organisms either. His views align with the sentiments expressed by notable figures in the field of unidentified aerial phenomena or UAP research. For instance, Luis Elizondo, the former head of the Pentagon's UAP task force, has said in interviews that there exists an entire dimension of reality, to put in his own words, right under our noses. Robert Bigelow, a well-known defense contractor who actively researched paranormal phenomena through his now-closed company, Bigelow Aerospace, has stated that aliens may be closer than we think, hinting at the possibility that these entities or organisms exist in proximity to our everyday lives, yet remain invisible to us. Similarly, Chai Meshed, the former head of Israel's space program, has offered particularly compelling insights that parallel Nolan's findings. In a recent interview, Eshed discussed observations of cattle mutilations that were captured on high-speed cameras. These recordings reveal amorphous shapes appearing during the incidents, suggesting a connection to the shadow biome concept. Jacques Vallée, a pioneering ufologist and computer scientist, has also explored concepts related to the nature of UFOs and their potential ties to our understanding of consciousness and reality. Valley has often suggested that phenomena attributed to extraterrestrial beings may have more to do with interdimensional entities or alternate states of consciousness than with traditional alien encounters. The hypothesis that such beings can only penetrate our reality for mere microseconds opens up new avenues for exploration in both scientific research and philosophical inquiry. This convergence of ideas suggests a range of possibilities regarding the nature of life and consciousness, forcing us to reconsider what it means to coexist with entities that are just beyond our perceptual grasp. While it may seem far-fetched for now, we must not forget that at one point in history, the idea of microorganisms, viruses, and prions was also likewise far-fetched, but eventually proven true. For now, we can get some additional perspectives on the matter. Bubble universes and the many worlds interpretation. Alexander Vilenkin is a distinguished theoretical physicist, renowned for his contributions to cosmology, particularly in the study of the universe's origins and its large-scale structure. He has significantly shaped our understanding of cosmic phenomena. His research delves into some of the most profound questions about the universe. One of his seminal contributions is his exploration of the concept of cosmic inflation, originally proposed by American physicist Alan Guth in 1980. This theory suggests that in the first fractions of a second following the Big Bang, the universe experienced a rapid and exponential expansion. The idea of inflation was proposed to address several puzzling features of the universe that the traditional Big Bang model could not explain. One of the main issues was the horizon problem, which refers to the question of why different regions of the universe, which should have been too far apart to have interacted with each other, appear to have the same temperature and physical properties. Inflation offers a solution by proposing that the universe was once small enough for these regions to have been in contact before rapidly expanding. Another problem inflation addresses is the flatness problem, which concerns the fact that the universe appears to be geometrically flat rather than curved. Inflation theory explains that the rapid expansion smoothed out any initial curvature, making the observable universe appear flat. And this is not purely conjecture. Evidence supporting the theory of inflation comes from multiple observational sources. One of the strongest pieces of evidence is found in the cosmic microwave background, or CMB radiation, which is the faint afterglow of the Big Bang. Data from experiments like the Wilkinson Microwave Anisotropy Probe and the Planck satellite have shown small temperature differences in the cosmic microwave background radiation. These tiny differences match what inflation theory predicts. Basically, when the universe expanded incredibly fast right after the Big Bang, small random changes called quantum perturbations were stretched out to much larger sizes. Over time, these stretched-out changes became the seeds that formed galaxies and the other large structures we see in the universe today. Additionally, the large-scale structure of the universe, including the distribution of galaxies and cosmic voids, aligns with inflationary predictions. The idea that small initial quantum fluctuations, amplified during inflation, gave rise to the diverse and large-scale structures we see today has become a cornerstone of modern cosmological theory. Despite its successes, inflation remains a theory, and some open questions and alternative models still exist. Some cosmologists question whether inflation really happened or if it is the best explanation for the early universe's behavior. Others propose modifications to inflationary theory or explore alternative mechanisms that could explain the same observed phenomena. However, inflation remains the leading theory due to its ability to solve key cosmological problems and its predictive power. Vilenkin's work further extended the theory of inflation by proposing the idea of eternal inflation, where inflation continues in some regions of the universe, creating bubble universes within a vast multiverse. In this model, different bubbles can have different physical properties and constants, leading to the intriguing possibility that our universe is just one of many in an endlessly inflating cosmic landscape. Complementing the notion of bubble universes is the interpretation of quantum mechanics known as the many worlds interpretation. This interpretation proposes that every quantum event where a particle could exist in multiple states results in a branching of realities. Rather than collapsing into a single outcome, each possible outcome occurs in its own separate universe, leading to an infinite array of alternate realities. Vilenkin's work aligns with this perspective, suggesting that the universe is not a singular entity, but rather a vast collection of branching realities that coexist simultaneously. Each decision, event, or quantum fluctuation spawns a new universe, generating an ever-expanding multiverse of possibilities. If both theories hold true, it implies that our observable universe is just one of countless others, each governed by its own unique set of physical laws and circumstances. But what if we could peer through the barrier and make contact with those living in a different reality? Well, before we do, let's consider the problem from a philosophical angle first: historical attitudes toward unseen realities. For much of our history, humans have wondered about the unseen. However, it wasn't until the 16th century that some notable strides were made in philosophizing our relationship with such realities. Notably, John Dee, a polymath of the Elizabethan era, made notable contributions to the subject. Born in 1527, Dee was educated at Cambridge University and became known for his extensive studies in mathematics and astronomy. He was a prominent figure at the court of Queen Elizabeth I, where he served as an advisor and a scientific consultant. However, it was Dee's deep interest in the metaphysical that ultimately led him to explore the realms of the occult, where he sought to uncover the mysteries of the universe and the divine order he believed governed it. Similarly, Edward Kelly, a scryer and alchemist born around 1555, became known for his ability to communicate with spiritual entities through the practice of scrying, a form of fortune-telling, to gain mystical insights. He partnered up with Dee, and this marked a significant turning point in both their lives as they embarked on an ambitious quest to communicate with angels and explore other dimensions of existence. The duo even developed the Enochian language, a complex system of symbols and sounds that was deemed a divine language communicated to them by angels. This language, which consisted of unique phonetic sounds and a specific script, became a central component of their magical workings. They employed various tools and methods, including elaborate rituals and intricate geometric diagrams, to facilitate their communications with angelic beings. Dee meticulously recorded their encounters, producing extensive manuscripts that detailed their conversations and the profound insights they purportedly received from the celestial realms. Despite the profound nature of their work, Dee and Kelly faced significant controversies and skepticism. Critics questioned the authenticity of their claims, particularly in regard to Kelly's motivations and behavior. Known for his flamboyant personality and questionable ethics, Kelly's actions raised eyebrows, leading some to speculate that his primary interest lay in personal gain. Moreover, his reputation as a trickster and a charlatan cast a shadow over their collaborative efforts. Dee, on his part, maintained a steadfast belief in divine order and the importance of understanding reality through a spiritual lens. He viewed his work as a noble pursuit, driven by a desire to uncover the hidden structures of the universe and the will of God. Dee believed that by communicating with angels, he could gain insights that would not only benefit himself, but also humanity as a whole. This quest for knowledge was deeply intertwined with his view of the cosmos, where every aspect of existence was interconnected. Though their methods were unconventional and the outcomes inconclusive, what the two did manage to accomplish was generate a genuine interest in communicating with the unseen realities of our world, especially from an academic or scientific angle. Most notably, their pursuits influenced the development of theosophy in the 19th century, which attempted to blend science, philosophy, and spirituality. This, in turn, inspired figures like Helena Blavatsky and Rudolf Steiner, who explored similar ideas about the existence of spiritual planes beyond normal human perception. The fascination with unseen realities also contributed to the study of parapsychology in the 20th century, where researchers like J.B. Rhine at Duke University conducted experiments on telepathy and extrasensory perception. Even modern theoretical physics, particularly ideas about parallel universes and higher dimensions, echoes the early curiosity sparked by figures like Dee and Kelly. Before we move on to more recent developments in the idea, let's get some more historical context first. Cosmic consciousness and the soul of the world. Gustav Theodor Fechner, a pioneering figure in psychology and philosophy, profoundly influenced the understanding of the intricate relationship between mind and body. His work emerged in the 19th century, during a time when the scientific community was increasingly interested in bridging the gap between empirical observation and philosophical inquiry. Fechner's perspective emphasized that consciousness is not merely a byproduct of physical processes, but rather an integral aspect of the cosmos itself. He proposed that our mental experiences are deeply intertwined with the physical universe. At the heart of Fechner's philosophy lies the concept of cosmic consciousness, the idea of a universal awareness, or the soul of the world, that permeates all of creation. He claimed that consciousness is a fundamental property of the universe, like a cosmic fabric that interweaves all living beings. Fechner speculated that there exists a collective consciousness, a pervasive awareness that extends beyond individual minds. He argued that our individual perceptions are but fragments of a larger, interconnected whole. Fechner's reflections also delved into the possibility of dimensions or realms beyond ordinary human perception. He contemplated the existence of higher planes of reality, where consciousness might operate differently from our everyday experience. This exploration led him to propose that there are deeper layers of existence that remain hidden from our typical awareness, yet can be accessed through heightened states of consciousness. His work suggests that by expanding our understanding of consciousness, we might uncover these spiritual dimensions, thereby gaining insights into the true nature of existence. Fechner also integrated elements of spiritual philosophy into his scientific inquiry. He believed that the exploration of consciousness could reveal insights traditionally associated with mystical experiences. His openness to metaphysical concepts set him apart from his contemporaries, who often adhered strictly to empirical methods. Fechner's theories have influenced contemporary discussions in quantum physics and transpersonal psychology. His ideas regarding interconnectedness and the nature of consciousness resonate with theories in quantum mechanics that challenge traditional notions of separateness. In transpersonal psychology, a branch that delves into the spiritual and transcendent aspects of the human experience, Gustav Fechner's ideas about a collective consciousness have significantly shaped modern interpretations of how individuals are interconnected on both a psychological and spiritual level. Fechner proposed that consciousness is not confined to the human brain or body, but is instead a fundamental aspect of the cosmos itself, permeating all forms of life and matter. His concept of a soul of the world suggests that all living beings are linked by a universal consciousness that transcends individual minds. Now let's look at more modern interpretations of these ideas. Contributions of Roger Penrose. Born in 1931 in Colchester, England, Roger Penrose stands as one of the most influential figures in modern theoretical physics and cosmology. One of his most notable achievements is the development of Penrose tiling, a non-periodic tiling pattern that defies traditional symmetry in geometry. Unlike conventional patterns, which repeat predictably, Penrose tiling creates intricate aperiodic structures that never quite repeat. This fascinating mathematical discovery has profound implications for understanding the spatial dimensions of the universe, suggesting that hidden structures, much like the tiling, may exist beyond our ability to perceive them. In fact, Penrose tiling parallels natural phenomena like quasi-crystals, materials that exhibit ordered yet non-repetitive atomic structures, hinting at the idea that complex hidden geometries might be fundamental to the very fabric of reality. Penrose's partnership with renowned physicist Stephen Hawking also led to major breakthroughs in our understanding of the cosmos. Together, they explored the extreme environments of singularities, which are regions in space where gravitational forces compress matter into an infinitely dense point. Their work, culminating in the formulation of the singularity theorem, demonstrated that singularities inevitably arise from gravitational collapse, as seen in black holes. These regions, where the conventional laws of physics break down, open up possibilities for other dimensions or realities. At singularities, space-time behaves in ways that defy our usual understanding, prompting questions about whether alternate dimensions or even other forms of intelligent life might exist beyond the event horizon of black holes. Penrose's exploration of consciousness offers an equally fascinating challenge to the boundaries of human knowledge. He theorizes that consciousness is deeply intertwined with quantum effects inside the brain, particularly in structures called microtubules. This groundbreaking model, known as the orchestrated objective reduction theory, suggests that the brain operates at the quantum level, where minute particles behave in strange and unpredictable ways. Unlike traditional computational theories of mind, which liken consciousness to algorithms, Penrose argues that human awareness is a non-algorithmic process that arises from quantum phenomena. His ideas raise the tantalizing possibility that consciousness might not be confined to human beings, but could exist in forms we cannot yet perceive, possibly connected to other dimensions or planes of existence. If quantum mechanics governs the mind, it could mean that our consciousness can interact with realities or dimensions beyond our usual sensory limitations. Another major contribution from Penrose is twistor theory, which proposes that space-time is not merely the three-dimensional arena we perceive, but an abstract mathematical structure that can be described using twistor coordinates. Twistor theory has profound implications for the nature of fundamental forces and particles, implying that higher dimensional spaces may hold the key to a more complete understanding of the universe. It suggests that what we perceive as three-dimensional space could be part of a much more complex, multidimensional reality. This opens the intriguing possibility that beings or entities might exist in higher dimensions, largely invisible to us, but capable of influencing or interacting with our world. But perhaps Penrose's most ambitious and provocative theory is conformal cyclic cosmology, a model in which the universe undergoes endless cycles of expansion and contraction. In this model, each eon of the universe begins with a Big Bang and ends in a Big Crunch, with the transition between cycles forming a continuous, eternal process. Crucially, Penrose proposes that the remnants of one cycle provide the seeds for the next. This cyclical model not only challenges traditional linear views of time and space, but also introduces the notion of a vast, interconnected, and multidimensional reality that exists across eons. If such a model holds, it implies that entities, energies, or consciousness from previous cycles might still influence or interact with the current universe in ways we cannot fully understand. Cosmic inflation, multiverses, and string theory. Alan Guth, an American theoretical physicist and cosmologist, is renowned for his pivotal contributions to the field of cosmic inflation. Born in 1947, Guth's academic journey took him from MIT to becoming a leading figure in cosmology, fundamentally altering our understanding of the universe's early moments. His formulation of the inflationary universe theory in the early 1980s not only addressed critical issues within the Big Bang model, but also opened new pathways for exploring the nature of the cosmos. This also spawned the idea of multiple universes with multiple realities. But most interestingly, Guth's work also connects intriguingly with string theory, a leading candidate for a unified theory of physics. String theory posits that fundamental particles are not point-like, but rather one-dimensional strings that vibrate at different frequencies. This framework naturally leads to the consideration of higher dimensions beyond the familiar three spatial and one temporal dimension. In this context, the mechanisms of inflation could be seen as intricately linked to these extra dimensions, suggesting that the dynamics of our universe might be influenced by unseen dimensions shaping its evolution. To better understand the idea, consider how life would be in a two-dimensional world. Imagine you are a two-dimensional being living in a flat plane, much like the characters in a 2D video game. In this world, you can move forward, backward, left, and right, but the concept of up or down is entirely foreign to you. Now imagine someone rolls a ball toward you. As the ball moves closer, all you would perceive is a growing circle, its diameter expanding as it approaches and shrinking as it moves away. You wouldn't be able to see the ball in its full three-dimensional form. The idea of depth, an additional spatial dimension, would be incomprehensible and paradigm-shifting for this flat world. Is that not similar to how we, in our three-dimensional world, find it hard to grasp a fourth or fifth spatial dimension? Such higher dimensions might exist around us, but we are confined by the limitations of our perception and current understanding. Just as the 2D world cannot perceive the third dimension, we are likely missing entire layers of reality that higher dimensions would reveal. Guth's inflation theory, when combined with the possibility of extra dimensions, opens the door to questions about the very structure of our universe. These unseen dimensions could be crucial in explaining mysteries in physics that remain unresolved, such as the behavior of dark matter or the true nature of gravity. Now let's consider the other perspective. How would a being from a higher dimension perceive the realities of those living in lower ones? While playing a 2D game, we, as players existing in a three-dimensional world, are fully aware of depth, even though the game itself doesn't render it. Our understanding of 3D reality allows us to impose the idea of depth onto the flat world of the game, even though it would remain beyond the comprehension of the characters in the game if they were real beings. In much the same way, the idea of a collective consciousness or cosmic soul may seem beyond the grasp of our current understanding, bound as we are by the limitations of our three-dimensional existence. That leaves us with one more question, though. How many higher dimensions are there? A prominent figure in theoretical physics, Michio Kaku, might have the answer to this inquiry. Born in 1947, Kaku's journey in academia began with a passion for understanding the fundamental laws of nature. He earned his PhD from the University of California, Berkeley, and has since become a professor of theoretical physics at City College of New York. Kaku's career has been marked by his ability to bridge the gap between advanced scientific theories and the general public, making him a well-known face in science communication. Kaku has also made significant contributions to string theory, particularly in popularizing and expanding its concepts for both academic and general audiences. He co-founded the field of string field theory to describe string theory using the tools of quantum field theory. This approach helps to integrate string theory with existing frameworks in physics. Kaku has also worked on the implications of string theory for higher dimensions, proposing that our universe could have up to 10 or 11 dimensions. His research explores how these extra dimensions could influence fundamental forces and particles. He has been instrumental in discussing the idea of a multiverse, where different universes may have varying physical laws and constants. On top of his contributions to theoretical physics, Michio Kaku has penned notable books such as Hyperspace and The Future of the Mind. In the former, Kaku delves into the implications of these extra dimensions for our understanding of the universe, illustrating how they could influence the fundamental forces of nature. For instance, Kaku illustrates the idea of extra dimensions by describing how fundamental forces like gravity and electromagnetism could be influenced by these unseen dimensions. He also discusses the concept of compactification, where additional dimensions are curled up so small that they are imperceptible to us, much like how the surface of a garden hose appears one-dimensional from a distance but contains additional dimensions when viewed up close. Moreover, Kaku elaborates on the proposals of string theory, which postulates that particles are not point-like, but rather one-dimensional strings vibrating in multiple dimensions. To further clarify complex ideas, Kaku uses real-world examples, such as how these vibrations determine the properties of particles, much like how the sound of a guitar string varies based on its tension and length. The Future of the Mind shifts focus to neuroscience, examining how advancements in brain research could reshape our understanding of consciousness, memory, and thought. Kaku discusses the possibilities of mind uploading, telepathy, and the development of technologies that could enhance cognitive functions. Interestingly, this idea is analogous to cosmic consciousness from higher dimensions, the same way that the use of shades and sizes to convey depth in a two-dimensional reality is analogous to the real thing in our reality. If we were to establish contact with beings from higher dimensions, the world as we know it and everything in it would never be the same. For now, we can only wait for the next big breakthrough. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.